Java polymorphism. Polymorphism in Java. Polymorphism is a core concept in object-oriented programming, OOP, that allows objects of different types to be treated as if they were of the same type. It enables you to perform a single action in different ways. There are two main types of polymorphism in Java. 1. Compile-time polymorphism, method overloading. Occurs during compilation. Involves multiple methods with the same name but different parameter lists within a class. The compiler determines which method to call based on the arguments passed. Java. Class calculator. Public int add, int a, int b. Return a plus b. Public double add, double a, double b. Return a plus b. 2. Runtime polymorphism, method overriding. Occurs at runtime. Involves a subclass overriding a method from its superclass. The actual method to be executed is determined at runtime based on the object's type. Java. Class animal. Public void make sound. System.out.println, animal makes a sound. Class dog extends animal. Add override. Public void make sound. System.out.println, dog barks. Key points. Polymorphism enhances code flexibility and reusability. Method overriding is the foundation for dynamic binding. Polymorphism is often used in conjunction with inheritance. Example demonstrating both types of polymorphism. Java. Class shape. Public void draw. System.out.println, drawing a shape. Public double area, inside. Return side asterisk side. Class circle extends shape. Add override. Public void draw. System.out.println, drawing a circle. Public double area, int radius. Return math.py asterisk radius asterisk radius. Class rectangle extends shape. Add override. Public void draw. System.out.println, drawing a rectangle. Public double area, int length, int breadth. Return length asterisk breadth. In this example, draw demonstrates method overriding, runtime polymorphism, while area, with different parameter lists demonstrates method overloading, compile time polymorphism. An inner class, or nested class, is a class defined within another class. They provide a way to logically group classes and enhance code organization. Types of inner classes. There are 4 primary types of inner classes. Member inner class. Declared within a class but outside of any method. Can access all members of the outer class, including private ones. Requires an instance of the outer class to create an instance of the inner class. Static nested class. Declared within a class using the static keyword. Can access only static members of the outer class. Can be instantiated without an instance of the outer class. Local inner class. Declared within a method or block. Can access final variables and effectively final variables from the enclosing scope. Has limited scope. Anonymous inner class. A special case of a local inner class without a name. Typically used for implementing interfaces or extending classes. Example. Java. Class outer class. Int outer variable equals 42. Class inner class. Int inner variable equals 10. Void display. System.out.println, outer variable, plus outer variable. System.out.println, inner variable, plus inner variable. Static class, static nested class. Static int static nested variable equals 20. When to use inner classes. Logical grouping, to group related classes. Access to outer class members, when an inner class needs to access private members of the outer class. Event handling, for implementing event listeners. Adapter patterns, for creating adapter classes. Key points. Inner classes provide a way to encapsulate related classes. Member inner classes have access to all members of the outer class. Static nested classes can be accessed without an instance of the outer class. Local and anonymous inner classes are used for specific scenarios. 2. Java abstraction. Abstraction is a fundamental concept in object-oriented programming, OOP, that focuses on hiding implementation details and exposing only the essential features of an object. It simplifies complex systems by providing a higher-level view of the functionality. In Java, abstraction is achieved primarily through two mechanisms. Abstract classes. A class declared with the abstract keyword can contain both abstract and concrete methods. Cannot be instantiated directly. Serves as a blueprint for subclasses. Java. Abstract class shape. Abstract void draw, / abstract method. Public void fill color, string color. System.out.println, filling with color, plus color. Interfaces. A completely abstract class. Contains only abstract methods and constants. Multiple inheritance is possible through interfaces. Provides a contract for classes to implement. Java. Interface drawable. Void draw. Key differences between abstract classes and interfaces. Feature. Abstract class. Interface. Methods. Can have both abstract and concrete methods. Only abstract methods. Variables. Can have instance and static variables. Can only have static final variables, constants. Inheritance. Single inheritance, but can implement multiple interfaces. Multiple inheritance supported. Constructor. Can have constructors. Cannot have constructors. Access modifiers. Can have access modifiers. Members are implicitly public. Export to sheets. When to use which. Abstract classes, when you want to share code among related classes, have a default implementation, and allow subclasses to override methods. Interfaces, when you want to specify a behavior that unrelated classes must implement, or when you need multiple inheritance. Example. Java. Class circle extends shape implements drawable. Add override. Void draw. System.out.println, drawing a circle. Benefits of abstraction. Improved code readability, by focusing on essential features. Increased maintainability, by hiding implementation details. Enhanced flexibility, by allowing for different implementations of the same interface. Better code organization, by grouping related functionalities. 3. Java interface. Java interfaces. An interface in Java is a blueprint of a class. It defines a set of methods that a class must implement. An interface is a purely abstract class. It cannot be instantiated. Key characteristics of interfaces. Abstract methods. All methods in an interface are implicitly public and abstract. They have no method body. Constants. All variables in an interface are implicitly public, static, and final. They are essentially constants. No constructor. Interfaces cannot have constructors. Multiple inheritance. a class can implement multiple interfaces. Syntax. Java. Interface name. / abstract methods. Void method 1. Void method 2. / constants. Int constant underscore value equals 10. Implementing an interface. A class implements an interface using the implements keyword. It must provide concrete implementations for all abstract methods defined in the interface. Java. Class My class implements interface name. Public void method 1. / implementation. Public void method 2. / implementation. Why use interfaces? Achieving abstraction, interfaces provide a clear contract for classes to follow. Multiple inheritance. Java doesn't support multiple inheritance of classes, but it can be achieved through interfaces. Loose coupling. Interfaces promote loose coupling between classes. Polymorphism. Interfaces enable polymorphism through the use of reference variables. Example. Java. Interface drawable. Void draw. Class rectangle implements drawable. Public void draw. System.out.println, drawing a rectangle. Default and static methods, Java 8 and later. Default methods, methods with a body in an interface, introduced in Java 8. They provide default implementations for methods. Static methods, methods with a body in an interface, introduced in Java 8. They can be called directly on the interface without an instance. Java. Interface My interface. Void method 1. Default void method 2. System.out.println, default method implementation. Static void static method. System.out.println, static method. Java enums. Java enums. Enums, enumerations, in Java provide a way to define a set of named constants. They are used to represent a fixed set of values. Basic structure. Java. Enum day. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Key characteristics. Constants. The values defined within an enum are constants, implicitly public, static, and final. Class-like. Enums are essentially classes that extend java.lang.enum. Iteration. You can iterate over enum values using a for each loop. Methods. Enums can have methods and constructors. Type safety. Enums provide type safety, preventing invalid values. Example. Java. Enum level. Low, medium, high. Public class enum example. Public static void main, string args. Level myvar equals level.medium. System.out.println, myvar. Advantages of using enums. Readability. Improve code readability by using descriptive names. Type safety. Prevent invalid values. Efficiency. Enums can be more efficient than using int constants. Extensibility. Enums can be extended with methods and fields. Common use cases. Representing days of the week, months, or seasons. Defining error codes or status values. Creating custom data types with a fixed set of values. Additional features. Enum set, a specialized set implementation for enums. Enum map, a specialized map implementation for enums. Example with methods and constructors. Java. Enum planet. Mercury, 3.303 times 10 to the power of 23rd, 2.4397 times 10 to the power of 6th. Venus, 4.869 times 10 to the power of 24th, 6.0518 times 10 to the power of 6th. Earth, 5.976 times 10 to the power of 24th, 6.3781 times 10 to the power of 6th. Mars, 6.421 times 10 to the power of 23rd, 3.3972 times 10 to the power of 6th. Jupiter, 1.901 times 10 to the power of 27th, 7.1492 times 10 to the power of 7th. Saturn, 5.688 times 10 to the power of 26th, 6.0268 times 10 to the power of 7th. Uranus, 8.686 times 10 to the power of 25th, 2.5559 times 10 to the power of 7th. Neptune, 1.024 times 10 to the power of 26th, 2.4746 times 10 to the power of 7th. Private final double mass, / in kilograms. Private final double radius, / in meters. Planet, double mass, double radius. This dot mass equals mass. This dot radius equals radius. Public double mass, return mass. Public double radius, return radius. / more methods and fields. Java user input. Java provides several ways to capture user input from the console. The most common methods are using the scanner class and the buffered reader class. Using the scanner. The scanner class is generally preferred for its simplicity and ease of use. Java. Import java.utility scanner. Public class user input example. Public static void main, string args. Scanner equals new scanner, system.in. System.out.print, enter your name. String name equals scanner.nextLine. System.out.print, enter. An integer. Int number equals scanner.nextInt. System.out.println, hello, plus name plus. System.out.println, you entered, plus number. Scanner.close, / close the scanner. Key points. Import the java.utility scanner class. Create a scanner object to read input from system.in. Use appropriate methods like nextLine, nextInt, nextDouble, etc., to read different data types. Close the scanner after use to release system resources. Using buffered reader. The buffered reader class offers more flexibility and efficiency for large input, but it requires more handling. Java. Import java.io.bufferedReader. Import java.io.io exception. Import java.io.inputStreamReader. Public class user input example. Public static void main, string args, throws IO exception. Buffered reader equals new buffered reader, new input stream reader, system.in. System.out.print, enter your name. String name equals reader.readLine. System.out.print, enter. An integer. Int number equals integer.parseInt, reader.readLine. System.out.println, hello, plus name plus. System.out.println, you entered, plus number. Key points. Import necessary classes, buffered reader, input stream reader, and IO exception. Create a buffered reader object to read input from system.in. Use readLine, to read a line of text. Convert the input to the desired data type using methods like integer.parseInt. Handle the IO exception that might occur during input/output operations. Choosing the right method. For most basic input scenarios, scanner is generally preferred due to its simplicity. For large input volumes or performance-critical applications, buffered reader might be more suitable. Consider the potential for exceptions and error handling when using buffered reader. Additional notes. Always validate user input to prevent unexpected behavior. Consider using regular expressions for complex input parsing. For graphical user interfaces, GUIs, use components like text fields and buttons to capture user input. Java input. In Java, user input can be obtained using several classes, but the most common method is using the scanner class from the java.util package. Here's a basic example of how to read different types of input from the user. Step 1. Import the scanner class. Import java.utility-scanner. Step 2. Create a scanner object. Scanner equals new scanner, system.in. Step 3. Read different types of input. Here are examples for reading different types of data. 1. Reading a string. System.out.print, enter a string. String user input equals scanner.nextLine. System.out.println, you entered, plus user input. 2. Reading an integer. System.out.print, enter an integer. Int number equals scanner.nextInt. System.out.println, you entered, plus number. 3. Reading a double. System.out.print, enter a double. Double decimal equals scanner.nextDouble. System.out.println, you entered, plus decimal. 4. Reading a boolean. System.out.print, enter true or false. Boolean bool value equals scanner.nextBoolean. System.out.println, you entered, plus bool value. Step 4. Closing the scanner. It's a good practice to close the scanner when you're done with it. Scanner.close. Example program. Here's a full example program that takes different types of input from the user. Import java.utility-scanner. Public class user input example. Public static void main, string args. Scanner equals new scanner, system.in. / reading a string. System.out.print, enter your name. String name equals scanner.nextLine. System.out.println, hello, plus name plus. / reading an integer. System.out.print, enter your age. Int age equals scanner.nextInt. System.out.println, you are plus age plus years old. / reading a double. System.out.print, enter your height in meters. Double height equals scanner.nextDouble. System.out.println, your height is plus height plus meters. / reading a boolean. System.out.print, are you a student? True / false. Boolean is student equals scanner.nextBoolean. System.out.println, student status, plus is student. / closing the scanner. Scanner.close. Notes. When switching from reading a number to reading a string, you may encounter issues because nextLine can pick up the new line character left in the buffer by nextInt, nextDouble, etc. A common workaround is to add an extra nextLine call after reading a number before reading a string. Example. Scanner.nextLine, / consume the leftover new line. This should cover the basics of handling user input in Java. Let me know if you need any further assistance. ArrayList is a dynamic array implementation in Java. It's part of the java.util package and provides a resizable array-like structure. Unlike traditional arrays, array lists can grow or shrink in size as needed. Key features. Dynamic size can automatically adjust its size based on the number of elements. Insertion order maintains the order in which elements are added. Allows duplicates, can store duplicate elements. Random access, elements can be accessed directly using their index. Non-synchronized, not thread-safe. Declaration and creation. Java. Import java.utility ArrayList. Public class ArrayList example. Public static void main, string args. ArrayList string names equals new ArrayList. / create an ArrayList of strings. Common operations. Adding elements. Java. Names.add, Alice. Names.add, Bob. Names.add, Charlie. Accessing elements. Java. String first person equals names.get, 0, / access the first element. Removing elements. Java. Names.remove, Bob, / remove by value. Names.remove, 1, / remove by index. Iterating over elements. Java. 4. String name, names. System.out.println, name. Checking size. Java. Int size equals names.size. Example. Java. Import java.utility ArrayList. Public class ArrayList example. Public static void main, string args. ArrayList integer numbers equals new ArrayList. Numbers.add, 10. Numbers.add, 20. Numbers.add, 30. / remove the second element. Numbers.remove, 1. / add an element at a specific index. Numbers.add, 1, 40. / iterate over the array list. 4. Int number, numbers. System.out.println, number. Important considerations. Generic type safety, use generic types to avoid runtime type errors. Performance, while array lists are generally efficient, consider other data structures like linked list or hash set for specific use cases. Synchronization, if thread safety is required, use vector or synchronize the array list explicitly.